Graphing with intercepts and finding slope from points and graphs. In the previous video, we talked about standard form. Standard form is ax plus by equals c. So this is an example of standard form, 2x minus 3y equals 12. Standard form is particularly good for finding intercepts, and we did some of that in the last video. We made tables and we put in 0 for y and 0 for x. Zeros are the easiest to work with because when you plug in 0 in the equation, that term just disappears. And this is what we're going to do here, and we'll use that information to graph the line. So the first thing we're going to do is find the x-intercept. If you're on the x-axis, think about this, if you're on the x-axis, you're not up or down at all, and y is 0. So for the x-intercept, y is 0. That means you're going to take that equation, 2x minus 3 times 0 equals 12. And that's what I was talking about. That thing is just gone. That leaves us with 2x equals 12. Divide by 2, and you can see that x would be 6. The x-intercept then is positive 6. The y-intercept, that's when you're on the y-axis, is when x is 0. Take the equation up above and plug in x is 0. 2 times 0 minus 3y equals 12. That's a negative 3y equals 12. Divide by negative 3, and y would be negative 4. Draw your line, and you've learned how to graph with intercepts. Notice that you really just solved two equations. The two equations were 2x equals 12. Look where they came from, 2x equals 12. And the other equation was 3y equals 12. Solving those two equations gave me the x and y intercepts. I could plot them on the axes and draw the line, and I can do that very quickly. The next thing we're going to talk about is how to find slope. Slope, which we call m, is defined as rise over run. Rise, remember, is the y distance, and run is the x distance. When you're given 2 points on a line, and you can actually use any 2 points, but notice we want to pick points that are in intersections so that we can actually use them. All we have to do is count the rise. Here it's 1, 2, 3. It's 3. And count the run. It's 1, 2, 3, 4, 5. The run is 5. And we can see in this case that the slope is rise over run 3 over 5. It turns out that we don't need to graph the line to find the slope. We can actually just look at the points. The y distance right here, 4, is the distance from the x-axis up to that point. It's 4. And the x distance of 1 is the distance from the x-axis to the triangle, 1. And notice that if I take 4 minus 1, those two numbers, 3 and 1, I get that rise of 3. All I had to do was subtract the y's. Typically, we'll call these general points. We'll put variables in there and we'll make a formula. This is going to be my second point, x2 comma y2, and this is going to be my first point, x1 comma y1. By the way, you might wonder about that subscript. It has nothing to do with powers. If I list a variable x1, x2, x3, and onward, this is the same thing as saying A, B, C. In other words, these are just different variables. The power of this is I can have an infinite number of variables with one letter. And the reason we want to use x2 and y2 and x1 and y1 is that way we know we're talking about an x and a y. That's what an ordered pair is. It's an x and a y. So these are just different variables, x1, x2, y1, y2. Notice that I took 4 minus 1. Well, instead of 4, I'm going to call that y2. And instead of 1, I'm going to call that y1. And what that means is that I'm going to subtract my y's to find the rise, which ended up being 3. Notice that from the y-axis out to the corner of the triangle here is 7, and there it is in the point. And this little bit that's not in the triangle, that distance is right there, it's 2. And again, if I take 7 minus 2, I get 5, and 5 was my run. And that's how we got 3/5, 3 over 5. Instead of 7, I'll use my variable, it's x2. Instead of 2, I'll use my variable, it's x1. This means subtract the x's to find the run. That means that slope in general is rise, subtract the y's to find the rise, over run, subtract the x's to find the run. This is the formula for slope, and you may have seen it before, but now you know where it comes from. Don't get confused by all the fancy letters. y2 minus y1, this means you're going to subtract the y coordinates. x2 minus x1 means you're going to subtract the x coordinates. That's what that formula says. Let's use that formula to find the slope given a couple of points. My formula is y2 minus y1 over x2 minus x1. The common mistake here is to put the x on top. But y is the rise, it's up and down. X is the run, it's left and right. Think of the x-axis and y-axis. If I give you points like 8, -2, and 6, -10, I can find the slope by subtracting the y's. -2 minus, notice the minus is separate from the negative on the 10, over 8 minus 6. The important thing here is that if you start with -2, you must start with the same point below, the 8 below. -2 minus -10 is -2 plus 10. The double negative means add. 8 minus 6 below. This ends up being 8 over 2. And so the slope is 4, or 4 over 1. The rise would be 4, and the run would be 1. Typically, we'll just write that as 4, though, and we'll know that the run is 1. Another example, if my points were 5, how about -5, -7, and 3, -9, I'd find the slope by subtracting the y's up top. It doesn't matter which point you start with. Sometimes students see that x2, y2, and they think that means I've got to choose the second point first. It doesn't mean that. They're just different variables. x2, y2, that ordered pair is just a different ordered pair than x1, y1. And the order doesn't matter here, except if I start with this point above, and I pick the y, -9 minus -7, you must start with the same point below. Since I started with the -9 on top, I must start with the 3 below. 3 minus -5. Again, double negatives mean add. This is -9 plus 7, and this is 3 plus 5. That ends up being -2 over 8. Every fraction should be reduced. Notice that 2 and 8 are both divisible by 2. When you reduce a fraction or simplify a fraction, you just divide them both by their common factors. And these are both divisible by 2. Divide by 2, I get 1. Divide by 2, I get 4. So it looks like the slope is -1 over 4. By the way, when you rise -1, you actually go down. And when you run +4, you go to the right. Here we're going to practice finding the slope from graphs. Now, if you wanted to, you could write all the ordered pairs. 2, 2, 6, 5, and this one would be 3, negative 5, and this one would be negative 2, negative 2. And then you could use each pair to find the slope of the line, and do that again with the blue line too. But you don't need to do that. What you need to do is count the rise and the run. You can actually pick any 2 points on the line, but we've got points given to us, we'll use those. What you want to do is make a right triangle. That's how we find the rise and the run. A right triangle, there's a 90-degree angle right there. We can count this 1, 2, 3, 4, that's 4. And we can count this one, 1, 2, 3, it's 3. Now the direction we go as we go from point to point matters. Notice that when I'm going to the right, that's positive. Think of the x-axis. And when I'm going up, that's positive. So this line right here has a slope of rise over run 3 over 4. I could have started with the top point. If I did that, it would look a little different. Make sure you're paying close attention. If I started at the top point and went down to the bottom point, I would go to the left, and the left would be negative. Negative 1, 2, 3, 4, negative 4. And then from here, I would go down, and down would be negative. 1, 2, 3, negative 3. Notice rise over run is negative 3 over negative 4. And yes, these two are the same because a negative divided by a negative is a positive. These are both 3/4, and 3/4 is the slope of the blue line. There's a common mistake with the red line. Notice the difference between the two. The slope of the blue line is positive. As x increases, y increases. The line is heading up. The red line is heading down. And that is the number one reason students miss these. You've got to pay attention to where the line's going up or down, up and to the right or down and to the right. Let's make our triangle. Here's our right triangle to find the slope. We'll start at the top point. I'm going to go down and down 1, 2, 3, so that's negative 3. And then I'm going to go to the right, 1, 2, 3, 4, 5. I'm going to the right. That's in the positive direction. Notice that the slope of this line is rise over run. It's down 3 over 5. Now I could have done this. Starting at the bottom point looks just a little different. If I start right here and make my triangle, notice how it's different. If I'm going to go to the other point, I have to go up, which is positive, positive 1, 2, 3, positive 3. But then I go to the left, and going to the left, look at the x-axis. When I go to the left, 1, 2, 3, 4, 5, that direction, it is negative 5. And rise over run ends up being positive 3 over negative 5. Fraction is a division problem. When you have one negative, your answer is negative. Both of these are negative 3/5. Here's some questions from your assignment. This assignment goes quite a bit faster than the last two. First thing we're going to do is find the slope. Now you have to find obvious points at grid intersections. I can see this hits the origin. That's an obvious point. Follow the line up and look for the next point where it hits an intersection. Looks like right there. And make a triangle. And you can make it on either side. It doesn't matter. Count the rise and the run. 1, 2, 3, 4. That's positive 4. I'm going to the right. I'm going up. That's positive. 1, 2, 3, 4, 5, 6, 7. Up 7. Rise over run is 4 over 7. What is the y-intercept as an ordered pair? This thing hits the y-axis at the origin. The coordinates of the origin are 0, 0. the x-intercept as an ordered pair. This thing hits the x-axis at the origin. So the ordered pair is again 0, 0. The x and y-intercepts are both 0. The last question had a positive slope. This line is heading down and to the right. It has a negative slope. Again, it hits the origin though. That's a good point. Follow the line up or down, your pick, and look for an obvious point. Looks like there's one right here, but there's also one right here. And make a triangle. Rise over run. The run is 2. I'm going to go down. Notice the down 1, 2, 3, 4, 5, 6. Down 6 and right 2. That's a positive 2. So the slope is rise over run, negative 6 over 2, and that definitely simplifies. Negative 6 divided by 2 is negative 3. The slope is negative 3 or negative 3 over 1. The x-intercept and y-intercept are both the same here. They both hit the origin. It's 0 for x and 0 for y. The ordered pair then is 0, 0. Here we're going to use some intercepts to graph. This is when we make that table and we put those zeros in. For the x-intercept, y is 0. For the y-intercept, x is 0. If that confuses you, just think about when a line hits the x-axis. If it's down here on the x-axis somewhere, you know that y is 0. You don't go up or down at all. And if a point is on the y-axis, you don't go left or right at all. X is 0. We're going to solve two equations, but 0 makes it a lot easier. Negative 8x, there's my equation, minus 2 times 0 equals 8. You're just solving negative 8x equals 8. Divide both sides by negative 8, and x would be negative 1. So the x-intercept is negative 1. Plug in x is 0, negative 8 times 0 minus 2y equals 8. That drops out. Negative 2y equals 8. Divide both sides by negative 2, and y would be negative 4. Plot those 2 points, an x-intercept of negative 1 and a y-intercept of negative 4. Draw your line, and you've got it. We haven't talked about horizontal or vertical lines yet in this video. We'll do that in just a second here. Let's first of all finish the first two. Find 2 points that are clearly at intersections. Looks like these two would work. And we're going up, which is positive, and right, which is positive. That's positive slope. It's up 1, 2, 3, 4, 5. Up 5 over 1. That's 5 over 1 or 5. This one, you can pick any 2 points you want. You can pick them right next to each other because they are, is down 1. That's a negative 1. And over 1. Rise over run is negative 1 over 1, which is negative 1. For the next one, it's a horizontal line. And I always point out to my kids, think of a horizontal line like the floor, because the floor is horizontal. Then think about how floor is spelled. It's spelled with those O's. Think of those O's as zeros. A horizontal line has slope 0. If that doesn't make sense, watch. I'll pick any 2 points randomly. 1, 2. You can find the slope with any 2 points. Count the rise and the run. This line doesn't go up at all. It goes up 0. But it does run because the 2 points I picked are 1, 2, 3, 4 apart. But 0 divided by anything is 0. This line has a slope of 0. A vertical line is different though. A vertical line is like the wall. It's up and down. Does the wall have a slope? Slope is a measurement of steepness. Would you call your wall steep? Let's look. Rise over run. The rise, I picked 2 points randomly, is 1, 2, 3. The run left and right is 0. You'll notice that if you punch out in your calculator, it says error. That's because this has no answer. It is undefined. Undefined is the mathematical correct term. In WANMAP, rather than type undefined every time, we type DNE for does not exist. Last thing I want to point out here, 0 is a slope. So if you're thinking no slope, that's wrong. 0 is a slope. A vertical line, though, does not have a slope. So if you say no slope, I'm going to assume you mean vertical line because a vertical line does not have a slope. It does not exist. Undefined is the mathematical term there, though. These last few questions are just finding the slope given points, and that is the formula. y2 minus y1 over x2 minus x1. Subtract the y's up top, -8 minus -4. Notice the minus is separate from the negative on the number, over. Since I started with -8, I must start with the same point below. 3 minus 4. -8 minus -4 is -8 plus 4. 3 minus 4 is -1. -8 plus 4 is -4. And -4 divided by -1, two negatives when you divide, make a positive. It's +4. Got a big blank there, don't you? I do want to point out, if you didn't do this in that order, you could have gone in the other order and it wouldn't have mattered. I could start with this point. That's fine. In fact, let's do that with blue, just to show you. I'm going to start with this point here. It'd be -4 the y minus the other y, -8, over. Since I started with -4, I must start with the same point below, 4 minus 3. -4 minus -8 is -4 plus 8. 4 minus 3 is 1. This ends up being 4 over 1. Notice you still get 4. You get the same answer. What's important is that you start with the same point above and below. Another quick one. We subtract the y's up top and the x's below. That's 4. I'm starting with this y. Minus 4. And with the same point below, -8 minus -3. Well, that's 0 over -5. If you punch 0 divided by -5, your calculator will spit out 0. This is a slope of 0. Remember, this is like the floor. It's a horizontal line. Think of the O's as zeros. Last example. Let's find the slope. y2 minus y1 over x2 minus x1. We'll subtract the y's up top. How about 15 minus 1? Since I started with a 15, I must start with a 5. 5 minus 5, that's 14 over 0. We got a problem. This is undefined. This is when the calculator spits out an error. And in WAMAP, we type D and E, does not exist.